morning, Group B students. Today we're going to go ahead and move forward with Chapter 1, Part 2. We're going to go on to Section 1.7a. In 1.6, A and B and C, we study transformations of parent graphs. Today we're going to go ahead and analyze key aspects and key characteristics of those parent functions. Before we do though, let's do our bell work. If f of x equals x cubed, what is the equation of the function g of x that results when f of x, so my original equation, is shifted up 6 units and to the right 5 units on the xy coordinate plane? This is a type of question you could see on a standardized test because it's testing to see what you know about transformations of parent functions. So our original graph is x cubed. Let's see if we can narrow down our options. If it's shifted up 6 units, that's a plus 6. And if it's shifted to the right 5 units, that is a minus 5, right? Because it goes to the opposite direction, 5 units. Okay, so let's go through our options and see which one has a plus 6 and a minus 5. F does not, G does not, H does, that's a possibility, J does not, and K does not. Must have a plus 6 to go up 6 units, like this one does, and a minus 5 to go right 5 units. So that narrowed it down to H is our correct answer. Let's go ahead and move on with our notes. Today, like I said, we're going to analyze different aspects of parent functions, and one aspect of parent functions is talking about where it's increasing, decreasing, and constant. Functions can be described by stating when the y value is increasing, decreasing, or constant. So increasing is just like how we would think, going up. Decreasing is where the graph is going down. And constant would be like where it is a flat line. Going across like that. A flat line is constant. However, the intervals, so the notation that we're going to use today, on which the function is increasing, decreasing, or constant, are based on the x values. So we're saying what the y is doing, but our notation is going to be in terms of the x values. Okay, so let's try some examples. First one, remember the interval is in terms of the x value of the domain. State the intervals on which the value of y is increasing, decreasing, or constant. So I'm going to write out I for increasing, D for decreasing, C for constant. Let's analyze our graph. There's arrows on either end of our function because it is a parabola. It opens up. And let's find where it is from the left side. From the left side, it's decreasing. My interval is from negative infinity all the way to 0. You saw how I moved my pen down because it was decreasing from negative infinity to 0. Remember, that's based off your x values. Also, on our notation for today, you're going to want to use parentheses. Brackets don't matter anymore. That was for domain and range. We're talking about increasing, decreasing, constant, so we're just going to use parentheses. After 0, what happens to my function? Right, it increases. So from 0 to positive infinity, the graph is going up, and it's increasing. Constant, there's nowhere my graph is a flat line, so you just say none. There's no interval where it is constant. Good, let's go ahead and try B. B, I'm going to do the same thing. Increasing, decreasing, and constant. So as I look at the left side of my graph, it's going on up. So it's increasing. That interval is from negative infinity, because it's on the negative side, to negative 1. It's on the negative side of the x-axis, to negative 1. After negative 1, what happens with my graph? Right, it flatlines. So that would be constant. Between negative 1 to 1, it's constant. And then what happens after I touch 1? It increases again. So we're going to use that U symbol to join the pieces together. Start back at 1, and then it goes up. So it increases to positive infinity. My graph never decreased because here it was increasing on both those intervals, and here it was a flat line. So on the decreasing, you could just say none, because it never went down. The way I like to think about these is like a roller coaster, right? A roller coaster, you're starting down and then it increases back up, where you flatline and wait for the big drop and then you come back down. So that's the way I like to think about increasing, decreasing, constant. You're going up, flatline, and then back down, kind of like a roller coaster. Remember that's based on your x intervals though. That's important to remember, and use parentheses. Next thing we can do to analyze parent functions in different kind of graphs is talk about their minimum and maximum values. The minimum, like it sounds, is a low point in the graph, and it's where the graph switches from decreasing to increasing. So from where it goes down to where it comes back up. That is where the minimum point is, right there at that low point in the graph. A maximum is just like it sounds as well. It is a high point in the graph. High point. And it's where the graph switches from increasing to decreasing. Increasing to decreasing. Right here is where that maximum value is going to be. Okay, and you'll want to use a calculator on these problems because the graphs can be kind of difficult to see where the min and max is. Let's look at the picture though I have on the board. Where are my minimum values? Your minimum values are where your low points are. So here's a low point in my graph, and here's a low point in my graph, the dips. So I have two minimums. When you write your minimums, you want to state what the y values are. So min and max is based off the y value. I have a minimum, looks like right here at -3. So I have a minimum at -3. I also have a minimum right here at -1. Okay, so I have two minimum points because I had two low points in my graph. Let's go look at the maximums. The maximums are the high points in my graph. Again, those are the y values that are the high points in your graph. So as I look here, there's a high point. It has a y value of 2. And here's another high point that is a y value of 1. Okay. So this graph had minimums and maximums. Sometimes you'll run across both in a graph, sometimes you won't. So just make sure you know the difference, minimum and maximum. Let's go ahead and go through a few examples. It says, use a calculator, sketch the graph, and state any minimum or maximums. So let's go ahead and type this one in the calculator so you can see how it looks. Okay, let's go ahead and type in the first one. F of x equals x squared plus 3. So on my calculator, I'm going to go to x squared plus 3 and then hit the graph key in the upper right-hand corner. And there's my graph. You'll notice that it is a parabola because it's a quadratic equation. If you want to find the points on your actual graph, what you can do is hit the second button, so the blue button, and then graph again, and it's going to pull up a table of all the values that you need to graph that equation. So that's pretty nice on a graphing calculator. If you didn't know that, you can go to this second graph key, and it will pull up a table of all the ordered pairs you would need to graph that equation. So looking at our graph, this is what the picture should look like. Those three ordered pairs. And we got that just by looking at the table and copying the graph down. -1, 4, 0, 3, and 1, 4. And then I just drew the graph. Now let's look at our minimum and maximum values. Which one do I have here, a minimum or a maximum? Right, a minimum, because I have a low point. And that min has a value of 3. So that's all I need to state. Has a minimum value at 3, because that's what the y value is at that ordered pair. Okay, so that's a minimum. Let's go do D. Again, let's type in the function into the calculator. Okay, next one. We're going to clear out the previous function and type in the new one. -x⁻³ power, arrow over, plus 2x⁻², then hit the graph key, and there's your graph. Again, to get the table, you're going to go to second, graph, and there's your table of values that you can use to plot it. So looking from the calculator, we should get a graph that looks like this. -1, 3, 0, 0, 1, 1, 2, 0, And then from the picture, I can see that it connects and comes back down, just like that. Okay, let's go do our min and max. My minimum. Do I have a minimum? Yes. It's right here, a low point in the graph. The arrows don't matter because they extend forever. The low point in the graph, remember, is where it switches from decreasing to increasing, which is right here. At 0, 0, have a y value of 0. Max is the high point, which is right here in the graph. That's at the order pair 1, 1. My y value is 1. So that's how you do minimum and maximum when it comes to graphs. Let's try some, though, where you don't have to sketch it. This is more like what's on your homework today. F of x equals 2x squared minus 17.2x plus 31.4. So this one you don't have to sketch because that would be a very difficult graph to sketch, but you can find the minimum and maximum values. So let's go type that one in the calculator. So first thing you're going to do is clear out the function that was in there to begin with. Now we're going to go ahead and graph the new one. So 2x raised to the second power minus 17.2x plus 31.4. And then we're going to graph it. You can see there's our graph. Since we don't have to sketch it, I'm not going to worry about the table of points and things. But if you look at our graph, does this have a minimum or a maximum value? Right, it has a minimum because it's got a low point in the graph. How you find it in the graphing calculator is you go to second, trace. Then we're going to select the minimum key, so arrow down to where you see 3, and click enter. Now it's going to say left bound. So we know our minimum value is right here at the low point in the graph. So we want to move the spider, the little thing that you'll see right here, the spider key, we want to move that so that it's somewhere to the left of that minimum value. And you can choose anywhere to the left you want to. I'm just going to go right here and hit enter. Now it says to the right bound, so I'm going to go to the right of my low point, over here, click enter. Then it says guess, so I'm going to hit enter one more time. And there's my minimum value. Right there at 4.3 is the x, negative 5.58 is the y. Remember, with minimum and maximum, we care about the y value. So our minimum is at negative 5.58. So once you type this one in and you find the minimum, you should get a minimum value of negative 5.58. We're going to round all of these to 2 decimal places, so the nearest hundredth. And that has a minimum because the graph pointed up like that. Has a minimum there. Next one, g of x. Let's go type that one into the calculator. Exact same thing. Clear out the previous function and we'll type in the new one. Negative 0.8x squared, arrow over, plus 3.3x plus 3.7. And then we're going to hit the graph key, and there's a picture of our graph. You'll notice this one's also a U-shape, and it is pointing downwards. So as we look at this graph, does it have a minimum or a maximum? Right. The maximum is right here at the very top, so it is a maximum value. Let's go find it. Go to second, trace. Now, because we're looking for a maximum, I'm going to go down to where it says maximum and hit the enter key. Now you can see my spider is right here, and it says to the left bound again. So of the left side of my maximum point, I'm going to go somewhere on the left and hit enter. Then right bound, so now I'm going to go somewhere to the right side of that maximum point, and then hit enter, and then guess, hit enter one more time. And there's my maximum point. 2.06 is the x, 7.10 is the y. Remember, we care about the y value. So our y is at 7.10 for the maximum value. So once you type that one in, it looks like this. And that has a max. And And our maximum value, remember, is the y at 7.10. We're just rounding to 2 decimals on this one as well. Okay, so on your homework for these types of problems, please use a calculator. Just do what I did, find the min and max, and then round to 2 decimal places. The last thing we're going to talk to today about analyzing graphs is deciding whether a graph is even or odd. Now, I created a table on your notes just to kind of keep the two straight, because even and odd functions are different from each other. An odd function, so if we think about an odd number like 3, so if I give you the function x cubed, we think about what that graph looks like using our parent functions. Looks like the S shape or the snake shape. Geometrically, odd functions have what's known as rotational symmetry. Rotational symmetry. That comes from your geometry classes. Rotational symmetry, remember, meant that you could turn the graph 180 degrees and it would look the same as it started with. Okay? So if I spin that graph 180 degrees, it's going to look the exact same as I start with, which means that it has rotational symmetry. That's what an odd function looks like. An even function, think of an even number like, for instance, 2. So if I think of the graph x squared, which looks like this U shape, notice that the graph is foldable down the middle. So geometrically, even functions are foldable, meaning that I could fold them in half and they would match on top of each other. Okay? So odd functions, you can spin and they match. Even functions, you can fold and they match. That's geometrically. Algebraically, though, is the way we're going to study them. And all you basically do is look at the signs. So you're going to take f of negative x, so plug in a negative everywhere you see an x, and see if it equals negative f of x. So see if I plug in a negative into wherever there's an x, see if it's the same thing as multiplying the function by a negative, which meant all signs changed, right? You multiply by a negative, that flips the signs. That means it's an odd function. If it's an even function, then the original function, f of x, must be the same as if I plugged in a negative in place of all my x's, so that no signs changed. So these are just notes, but let's actually see how to apply whether a function is even or odd or neither. So as we look at our examples, state if the function is even, odd, or neither. We're just going to use our algebraic skills to decide whether they're even, odd, or neither. So remember, to test if it is even, I'm going to take f of negative x and just plug that in place of my x value. So take your negative and plug it in place of the x. Negative x squared plus 1. And then we're going to simplify that. Negative x squared. Think about if that's a negative 1x squared. Negative 1 squared is 1, and x squared is still x squared. So negative 1x squared, a negative squared is just a positive, so we get 1x squared plus 1. That one did not have an x, so I'm not going to put anything in its place. What do you notice about this function and the original one? Right, they're the exact same. No signs changed. So because no signs changed, this function must be even. Just looking back at our rules from the chart we just made. Plug in a negative for your x. We simplified. No signs changed. So it is an even function. Let's try the next one. G of negative x. Now, everywhere I see an x, I'm going to put that negative x in its place. There's another one, so I put negative x. And I'm going to simplify. Negative x cubed. Well, negative x cubed, negative times the negative is still a negative. So I get negative 1x cubed plus negative x. That can just stay negative 1x because it wasn't raised to any powers. What do you notice about the original function and our new function? Right, the signs changed. Originally, this was a positive, and this was a positive. But when I plugged in my negative x, now they changed to negatives. So since all the signs changed, this one is an odd function. Okay, so I plugged in a negative, simplified, and then all the signs changed. Let's try the last one. H of negative x. So everywhere I see an x, I'm going to put a negative x in its place. Squared plus 2, negative x, minus 1. Now I'm going to go through and just simplify it. Negative x squared, well, a negative squared makes a positive. 2 times negative 1 is negative 2x minus 1. Now we compare our two equations. What do you notice about the two equations? Right, some signs changed and some didn't. This one stayed positive. This one changed. And that one stayed the same. So because some changed and some didn't, this one is a neither. So some signs changed. Some signs changed, but others did not. Did not change. So because some signs changed and some didn't, this one is neither even nor odd. Okay, so that's how you determine algebraically if a function is even, odd, or neither. On your homework, this is the kind of problems that you'll be doing, plugging in a negative x in place of your x's. Simplify what you know about the function, use what you know about exponents, and then see if your signs changed. If they all changed, then it's odd. If no signs changed, it's even. And if it was kind of a half and half deal where some changed, some didn't, then it is neither on that function.